Hello dear friends, welcome to BYJU'S Exam Prep, the comprehensive learning preparation app for your competitive examinations. Now under this Sunday special Learn with Fun series, I am going to discuss one very interesting puzzle known as door puzzle. Dear friends, there are other variants for the same puzzle like 100 switch puzzle, 100 coin puzzle, etc. First, let us understand this particular puzzle. Then you can easily answer all other variants, my dear friends. Before starting the puzzle, this is about me. Myself, Sridhar Dhulipala. I am having 20 plus years of teaching experience and I am associated with BYJU'S from past 2 years. Dear friends, you can join my Telegram group CS_Sridhar to get regular updates about my classes on YouTube as well as app. Now let us see the puzzle. A building has 100 doors numbered from 1 to 100. All the doors are initially closed. There are 100 students numbered 1 to 100. The first student will go and open all the doors. Initially all the doors are closed, so the first student will open all the doors. See, this particular process of closing the opened door, opening the closed door is what is known as toggling. So the first student toggle all the doors, whereas second student will go and close the doors with even numbers. That is, second student toggle the doors whose numbers are multiples of 2. Third student toggle the doors whose numbers are multiples of 3. Fourth student toggle the doors whose numbers are multiples of 4, and so on. It continues for all the 100 students. After completion of 100 students, the question is, how many doors are open and what are those door numbers? That is the question. See, instead of solving this 100 door problem, first of all, let us consider a small variant. Here I am having 10 doors numbered from 1 to 10 which are initially closed. Assume that there are 10 students numbered from 1 to 10. So I am going to give the solution for this particular problem. This solution is generalized for 100 doors problem. If you properly understand, this solution can be generalized for even 1000 door problem also. So let us understand this particular solution for 10 door problem. 10 doors which are initially closed and there are 10 students. First, initially all the doors are closed. The first student will open all the doors. So here we call it as toggle. First student toggle all the doors. That is, initially they are all closed, so he opened all the doors. Second student toggle the doors whose numbers are multiples of 2. That is, second, fourth, sixth, eighth and 10th door. Here they are opened, so he closes. Third student toggle the doors whose numbers are multiples of 3. Third door open, sixth door closed, ninth door open, so they are toggled. Fourth student toggle the doors whose numbers are multiples of 4. That is, fourth and eighth door closed, so they are opened. Fifth student toggle the doors whose numbers are multiples of 5. That is, fifth and 10th doors are toggled. Sixth student toggle the doors whose numbers are multiples of 6. Sixth door only, so that is open now, so he closes it. Seventh student toggle the door number 7. Eighth student toggle the door number 8. Ninth student toggle the door number 9 and 10th student toggle the door number 10. So once all the student completes, what are the doors which are open? Clearly, the doors which are open are door number 1, door number 4 and door number 9. How many? 3 doors are open. And what are those doors? 1, 4 and 9. That is doors numbered 1, 4 and 9. Is there any specialty about these numbers? You can pause and write the answer. The specialty is these numbers are perfect squares. These are perfect squares. It is 1 square, it is 2 square, and it is 3 square. That is, the doors whose numbers are perfect squares are opened ultimately. And the same solution can be generalized for 100 door problem also. How many doors are open? What are those door numbers? So the doors which are opened are the perfect squares. That is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, and 10 square. How many are there? You can simply do 100 numbers are there, you just do square root of 100. You will get the answer. 10 numbers. So those are the perfect squares, my dear friends. And these are the doors which are opened ultimately. See, this is the solution, my dear friends. Let it be 100 door problem, yeah, 100 switch problem, yeah, 100 coin problem. In 100 switch problem, the situation is like on and off situation. Here it is close and open situation. There it is close means off, open means on. That's it. Same puzzle can be generalized for 100 switch puzzle also, my dear friends. Got it? Now we got the solution. I only given the solution, but I not given the reasoning. Now let us understand the reasoning for this particular solution. To understand the reasoning, let us consider a door whose number is 24. Consider the door number 24. Who will toggle this particular door? The students whose numbers are divisors of 24 will toggle this particular door. Because we know first student toggle with all the doors. That is, he toggle with all the numbers. You can say multiples of 1. Second student toggle with the doors whose numbers are multiples of 2. Third student toggle with the doors whose numbers are multiples of 3. Fourth student toggle with the doors whose numbers are multiples of 4, etc. So if you consider 24, this particular 24th door is toggled by the students whose numbers are actually divisors of 24. So first student toggle this particular door means it is closed originally. First student will open it. Then second student, because 2 is divisor of 24, second student toggle means open means he closes. Third student, because 3 is also divisor of 24, 3 also toggles means he open this particular door. Fourth student, 4 is also divisor of 24, 4 also toggle means open means he closes. Fifth student, no, 5 is not divisor of 24. Fifth student, do not alter the door number 24. Sixth, 6 is divisor, yes, so he open. 7, no. 8, he alters or he toggle, that is he closes. 9th, no, 9 is not divisor of 24. After that 8, what is the next divisor? 12. 12th student will open, and finally after 12 obviously next divisor is 24. 24th student will toggle the door. 24th student will close it. So initially the 24th door was closed and ultimately it is closed, because after 24 no other student will toggle with this particular door. No other student will toggle with this particular door. See, if you observe, how many divisors are there? Number of divisors of 24. Number of divisors of 24. How many divisors are there for 24? You can check. There are 8 divisors. And whenever a number or a door number is having even number of divisors, whenever a door number is having even number of divisors, yeah, even number of factors, it is ultimately closed. Because first factor will open, second factor will close it. Third factor opens, fourth factor will close it. Fifth factor will open, sixth factor will close it. So whenever a number is having even divisors, okay, if a number is having or number having even divisors or factors, if a number is having even divisors or factors, is ultimately closed. Why, sir? Because first factor will open. First factor means the student with that particular number. Second factor, that is student with that particular number, will toggle. So first factor will open, second factor will close it. So when it is having even factors, ultimately what happens? The door will be closed. Now, what are the numbers which are having odd factors? What are the numbers which are having odd factors? And those fellows will be ultimately opened. And that is the solution for this particular problem, my dear friends. And if you observe, if you take any perfect square, for 25, what are the factors? 1 is a factor, 5 is a factor, then 25 is a factor. It is having odd number of divisors or odd factors. You take any perfect square, for example 49, you take 1, 7 and 49. You take 64, 1, 2, then what happens? 4, 8, 16, then 32, then 64. Any other divisors? Sorry, 64. So it is having 7 divisors. It is having number of divisors, yeah, factors for any perfect square. Number of divisors, yeah, factors for any perfect square will be odd. Because it is having odd factors, what happens? Ultimately the door will be open. See, here it is closed, here it is open, closed, and it is open. So that is the solution for this particular problem, my dear friends. Okay, so that is the solution for this particular problem. So any number which is having even factors, so it is having even factors, it would be closed. Any number which is having odd factors, it would be open. And what are the numbers which are having odd factors? They are only the perfect squares. Only the perfect squares will have odd number of factors. Only perfect squares have odd number of factors. And that is the solution for this problem, my dear friends. So you just need to identify how many perfect squares are there from 1 to the given number. If it is 100, 10 perfect squares are there. If it is 1000, 1 to 1000, how many perfect squares are there? Those doors will be open. So this problem can be generalized for 1000 or 10,000 doors also, my dear friends. So what is the solution for this particular problem, my dear friends? How many doors are open? That is equal to number of perfect squares less than or equal to 100. You can just do root 100, you will get the answer, my dear friends. Root 100, you do it, you will get the answer. And what are those numbers? Write down 1, 4, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, and 10 square. So that is about this puzzle, my dear friends. Hope you like this particular puzzle. We'll meet in the next session with one more puzzle. Thank you.